pre-cal students. In this video, we are going to be studying the 6 trigonometric functions called sine, cosine, tangent, cosecant, secant, and cotangent. Now, most geometry classes cover these 3 right here, so those should sound familiar to you. Maybe some of you have had these 3. I would think most of you have not, okay? But these are what we call the 6 trig functions. And we're going to look at today finding values of these 6 trigonometric functions. Okay, and by the way, you should be very familiar with these abbreviations. Sine, of course, looks like the word sin, S-I-N. Cosine is C-O-S. Tangent is T-A-N. Cosecant is C-S-C. Secant is S-E-C. And cotangent is C-T-O, or C-O-T, excuse me. Okay, so there are the abbreviations. You should be familiar with those, and you'll see those a lot more throughout the class period, so you probably don't need to write those down. But sine, cosine, tangent, cosecant, secant, and cotangent. Okay, so your heading today is this. Go ahead and copy your heading down, please. Your heading is finding trig function values. Finding trig function values. That's your heading for today. And then go ahead and include today's date, please, so that you have organized notes. All right, let me get a drink here and we'll continue on. Okay, here we go. Take some really good notes, please. It is very important that you master using these 6 trig functions. You need to be very familiar with these 6 trig functions. They are the foundation of geometry, okay? The first thing you need to understand is that these 6 trig functions, are you ready for this? They are nothing more than a ratio. And they're the ratio of the sides of a right triangle. Or more specifically, they're the ratio of 2 sides of a right triangle. So when I ask you to find the sine of an angle, or cosine, or tangent, or cosecant, or secant, or cotangent, do you understand what I'm really asking you to find? I'm just asking you to find the ratio. Anyone can write a ratio. I'm just asking you to find the ratio of 2 sides of a right triangle. And by the way, it must be a right triangle. Okay? Now let me pause here. I want you to write some stuff in your notes you need to see, okay? So I'm going to go ahead and that's not a very good triangle. Let's try this again. I'm going to draw a triangle and then another triangle over here. Did not mean to do that, so let's go like this and this and this. There we go. And there we go. Okay, go ahead and draw a couple of triangles there. Let's label this a right angle. Let's call this 30 degrees. And let's call this 60 degrees, 30 and 60. And then we're going to label this side over here 2. And this side will be 4. And this side here will be 2 square root of 3. And then come over here. We're going to label this the same, a right triangle. We call this a 30, 60, 90 triangle. And then we're going to call the length of this side here 4. The length of this side is 8. And the length of this side here is 4 square root of 3. Now, before we get started, let me tell you this. These 2 triangles are completely drawn to scale. Okay, trust me, these are drawn perfectly right. And what I want to show you is this. And it's very important that you see this. Whenever I tell you the sine of a certain angle, like let's talk about the sine of 30 for a second. And here's 30 right here. If I said find the sine of 30, and let's just say you put this. Let's just say you put 2 over 4. Now, I'm not saying that is or is not the correct ratio, but if I asked you to find the sine of 30, and let's say you took this side and put it over this side, notice what you get for your answer. You get 1/2, 2 over 4. Now come over to this triangle here. If I asked you to find the sine of 30, and you use the exact same 2 sides, you would get 4 over 8, which also reduces to what? Yeah, you got it, 1/2. Now, by the way, trust me, actually, these are the two correct sides. And if you take your calculator right now, as long as you're in the degree mode, make sure you're in the degree mode. If you typed in the sine of 30, you would get 1/2. I guess what I'm trying to show you is simply this. I'm trying to show you that no matter what triangle you're dealing with, if you have the sine of 30 in one triangle or the sine of 30 in another triangle, it doesn't matter what the side lengths are as long as they're accurate measurements. You will get out the exact same answer, because as a right triangle increases in proportion, the ratio of the sides stay the same. Okay, so it's really, really important that you see that. Okay, but let's go ahead and continue on, and let's see if we can't look at this a little deeper. Now, so having said all of that, the only thing you're missing is knowing what two sides go with what trig function. That's all that you're missing. What two sides go with sine? What two sides of a right triangle go with cosine? What two sides go with tangent, etc., etc. And so here we go. Please copy this all in your notes. Copy all of this down, please. Having said that, here are the trig ratio formulas that you need. If I ask you to find the sine of angle x, you're going to use opposite over hypotenuse. If I ask you to find the cosine of angle x, you're going to use the two sides adjacent and hypotenuse. If I ask you to find the tangent of angle x, you're going to use these two sides here, opposite and adjacent. And by the way, notice this. Notice that cosecant and sine are inverses of each other. The sine of x is opposite over hypotenuse, and the cosecant of x is hypotenuse over opposite. Notice cosine and secant are inverses of each other. So, the cosine of x is adjacent over hypotenuse. The secant of x is hypotenuse over adjacent. Notice tangent and cotangent are inverses of each other. The tangent of angle x is opposite over adjacent, and the cotangent of angle x is adjacent over opposite. So please copy all these in your notes, and then we're going to learn to apply these to some problems in just a second, okay? So sine, cosine, tangent, cosecant, secant, cotangent, your 6 trig functions. Okay, let's apply these to a problem. So go ahead and copy this triangle in your notes if you would, please. And I want us to find the 6 trig function values for theta, for this angle right here. Well, the first thing you need to do is you really need to know all 3 sides. So you should know from geometry and algebra 1 and algebra 2, here's your right angle. If you go straight across, this is your hypotenuse, and this is a leg, and this is a leg. So let's use Pythagorean's theorem real quick, and let's find the hypotenuse. Remember, a leg squared plus a leg squared equals hypotenuse squared. You're probably familiar with that. A squared plus b squared equals c squared. I just like to use L, and H is for your unknowns. Okay, but it's the exact same formula. So here we go. One of your legs would be 3, so 3 squared. Another leg would be 4, so 4 squared equals hypotenuse squared. Well, 3 squared is 9, 4 squared is 16. 9 plus 16 is 25. 25 equals h squared. Take the square root of both sides, and 5 equals your hypotenuse. So now that we know all 3 sides of this right triangle, let's go ahead and find the sine, cosine, tangent, cosecant, secant, cotangent of theta. Let's start off with sine. Now the sine of theta is opposite over hypotenuse. We better label our sides. Circle the angle you're dealing with, and then always go straight across to the other side. Let me say that again. Circle the angle you're dealing with, and then go straight across to the other side. Okay, if you do that correctly, then you know this side over here is your opposite side. Now we all know the hypotenuse doesn't change. So your 5 is your hypotenuse. The only side left has to be your adjacent side. And that's how I always teach that. Circle the angle you're dealing with, go straight across. That's going to be your opposite side. And of course, we all know the hypotenuse. And so the only side left is your adjacent side. So the sine of theta is what? How do you find sine? Opposite over hypotenuse, or 4 over 5. So there we go. It's that easy. There, you just found the sine of theta is 4/5. Now let's find the cosine of theta. Well, cosine of x, or theta, whatever angle you're dealing with, is adjacent over hypotenuse. So 3 over 5. And now let's quickly find the tangent of theta. Now the tangent of the angle you're dealing with is opposite over adjacent. Well, that would be 4 over 3. And now watch how fast you can find the cosecant. We know that cosecant is the inverse of sine. So if sine is 4/5, then cosecant is 5/4. We know secant is the inverse of cosine. So if the cosine of theta is 3/5, then the secant of theta would be 5/3. You just flip this fraction, just like we did over here. And if the tangent of theta is 4/3, we know that cotangent is the inverse of tangent. And so if the tangent of theta is 4/3, then the cotangent of theta would be 3/4. Okay? 3/4. So there we go. Once you know the 3 lengths of the 3 sides of a right triangle, you can then find any of the 6 trig functions. Now let's take this a step further. Let's try something a little different. Let's say that I simply told you that cosine of theta is 5/7, and then I told you to find the other 5 trig function values. Well, let's not panic here. First of all, we don't care if our right triangle is drawn to scale. We don't really care about that. But let's go ahead and draw a right triangle. Okay, so go ahead and draw a right triangle in your notes. Hopefully yours will look a little better than mine. And it really doesn't matter where you put theta. Let's put theta right there. That's good enough, okay? So there we go. There's the angle we're dealing with. Now, notice what they've told you. They've told you the cosine of theta is what? 5/7. Now hold it. Let's go back a page. What is the ratio for cosine? Adjacent over hypotenuse. Adjacent over hypotenuse. So think about this. I know 5 has to be the what side? Adjacent. I know 7 has to be the what side? Hypotenuse. So I know 2 lengths of my triangle. Here's my right angle. I go straight across. Here's my hypotenuse. So my hypotenuse is 7. Now here's the angle I'm dealing with. If you go straight across, this is your opposite side right here. This is your hypotenuse. So the side left over right here must be your adjacent side. And look, we know the length of the adjacent side, 5. We're doing awesome. Okay? So now using Pythagorean's theorem, L squared plus L squared equals hypotenuse squared, we can very quickly find this last side over here. So one of my legs is 5. My other leg I'm looking for, and my hypotenuse is 7. So now I have 25 plus L squared equals 49. Now bring the 25 over and make it negative, and you're left with 24. And now let's take the square root of both sides. The square root of L squared is L, and the square root of 24 is the square root of 24. Now you're in pre-cal. In Algebra 1 and Algebra 2, you should have learned how to simplify your radicals. You're looking for perfect squares that divide into the radicand, which is 24, evenly. Well, I can think of a perfect square that goes into 24, 4. So I'm going to simplify the square root of 24 into 4 times 6, then cross off the 4, put a 2 on the outside because the square root of 4 is 2, and now you have your missing side. It's 2 square root of 6. Now, if you need to watch that again, then pause the video and back it up, okay? But now that we have found all three sides, remember we go fast in this class, okay? This is pre-calculus. Now that we have found all three sides of the right triangle, now we're going to go ahead and find the other trig functions, okay? Let me get some erasing going on here, and I think we will be good to go. So here we go. Let's find the sine of theta. Well, sine is opposite over hypotenuse, so 2 square root of 6 over 7. All right. The tangent of theta would be opposite 2 square root of 6 over adjacent. 2 square root of 6 over 5. Now here's where it gets a little tough, so please watch carefully. I want us to find the cosecant of theta, and cosecant's the inverse of sine. So cosecant would be 7 over 2 square root of 6. Now students, we really don't want a radical in the denominator here. And again, you should have learned this in Algebra 1 and Algebra 2. And that's called rationalizing a denominator. Rationalizing a denominator. You do not want this radical in the bottom. So you multiply the top and the bottom by the square root of 6. Okay? Now, 7 times the square root of 6 is 7 square root of 6. And if you take 2 square root of 6 times square root of 6, you will get 2 square root of 36. Okay, there's really a 1 right here. 2 times 1 is 2. 6 times 6 is 36. And now the square root of 36 is 6. So you really have 2 times 6, which is 12. So the cosecant of theta is going to be 7 square root of 6 over 12. You never want a radical in the denominator. Okay, now let's go ahead and take a look at secant. Secant, of course, is the inverse of cosine. So the secant of theta would be 7/5. And now be careful with tangent. We're going to have another radical situation in the denominator, okay? So here we go. The cotangent of theta is going to be 5 over 2 square root of 6. So we're going to multiply the top and the bottom by the square root of 6. 5 times the square root of 6 is 5 square root of 6. And then don't forget, we already did this multiplication before. We already took 2 square root of 6 times 6 earlier when we did our rationalization over here for cosecant, and we got 12 in the denominator. And by the way, never reduce. See this 6, see this 12? A lot of you think you can put a 1 here and a 2 here, and that's incorrect. 6 is what we call an inside number. It's under the radical. 12 is what we call an outside number. It's outside the radical. And so do not reduce an inside number with an outside number, okay? So you cannot reduce this. Now, if this 5 right here was a 6, then you could reduce 2 outside numbers. 6 goes into 6 once, and 6 goes into 12 twice. You can reduce outside numbers with outside numbers, and you can reduce inside numbers with inside numbers, okay? But we have 5 square root of 6 over 12. So the cotangent of theta equals 5 square root of 6 over 12. Wow, this is a lot of work. Okay, let's try another one here. Now you're on your own, okay? Now you're welcome to let the video run and kind of watch me do it if your confidence is very low. But I'd like you to pause the video and try this on your own if you're able to, and just see how you do, okay? But that's up to you. I'm going to go ahead and get started. So if you want to try this on your own, then please pause the video. All right, here we go. Okay, now cosecant of theta equals 4/3. Now if you'll go back a couple pages, you'll see that cosecant is hypotenuse over opposite. Hypotenuse over opposite. So what I really have here is I know 4 is my hypotenuse, and I know 3 is my opposite side. Okay, so I'm going to draw a little different right triangle this time just to be different. and I'm going to go ahead and put theta up top. It really doesn't matter where you put theta. Okay, now I know my hypotenuse is 4, and I know if I circle this angle and go straight across, this is my opposite side over here, and so my opposite side has a measurement of 3. So I'm missing my adjacent side. Here's my opposite side, here's my hypotenuse side, and here's my adjacent side. So we're missing one of our legs. So very quickly here, leg squared plus leg squared equals hypotenuse squared, and that would be 9 plus L squared equals 16. Bring the 9 over and make it a -9. Square root of, or L squared equals 7. Take the square root of both sides and you'll get leg equals square root of 7. So your adjacent side here is square root of 7. Okay? And now that you know all 3 sides, we're ready to hopefully very quickly find my other 5 trig functions. So here we go, hopefully pretty quickly. Are you ready? Here we go. So I'm going to go really fast. Sine of theta equals opposite over hypotenuse, so 3/4. Cosine of theta equals adjacent over hypotenuse, so square root of 7 over 4. Tangent equals, oh, we got some work to do on this one. Tangent of theta equals opposite over adjacent, 3 over square root of 7. We don't want this square root in the denominator, so we're going to multiply the top and the bottom by the square root of 7 to rationalize the denominator. 3 times the square root of 7 would be 3 square root of 7, and then square root of 7 times square root of 7 would be the square root of 49, and the square root of 49 is just 7. Please do not reduce this inside number right here with this outside number right here, okay? So there we go. The tangent of theta is 3 square root of 7 over 7. Okay, now let's come over here. Cosecant, as we already know, cosecant of theta is 4/3. And secant of theta would be, oh, we got to be careful here, it would be 4 over square root of 7. So we multiply the top and the bottom by the square root of 7. And we get 4 square root of 7. 4 times the square root of 7 is 4 square root of 7 over, well, the square root of 7 times the square root of 7 is just 7. The square root of 49, which is just 7. So I end up with 4 square root of 7 all over 7. Okay? And then lastly, let's take a look at cotangent. Now, cotangent of theta, you're welcome to flip this here, and that's totally fine. You will get 7 over 3 square root of 7. And of course, we're going to multiply the top and the bottom by square root of 7, square root of 7. And we're going to end up with 7 square root of 7 over 21. Now, where did I get 21? Well, thanks for asking. Let me show you. There's really a 1 right here. So 3 times 1 is 3. 7 times 7 would be the square root of 49. Now, the square root of 49 is really 7. So you really have 3 times 7, which is 21. Okay? So we're going to go ahead and put 21 right here. Now, notice something. If you don't reduce, you do lose points on a test or a quiz. You have an outside number of 7 and an outside number of 21. Now, when I say outside, what I mean is they're not under the radical. So you can reduce those two numbers. So 7 goes into 7 once, 7 goes into 21 3 times. 1 square root of 3 is the same thing as square root of 3 over 3. There we go. We did it. We found all of the trig values for this right triangle, and all that we knew was this information right here, and we could take it from there. Okay? All right, let's continue on. Lastly, let's learn to find trig values by using your calculator. Now, you did this in geometry, I'm sure. It's really easy. We have definitely saved the easy stuff for last, okay? But first, I want you to make sure your calculator is in the degree mode. If it's not, then you're going to miss all the problems we're doing. And all the problems we're going to do in your homework and in this video today are going to be in degrees, okay? So let's check your calculator and make sure it's in degrees. Now, if you have a different calculator, call me or email me or send me a picture of your calculator, and I'll try to help you find the buttons you need to push. But for a TI-83 or a TI-84, you should use the button right here, your mode button. So push mode, and when you do, you're going to see a bunch of words appear on the screen. But if you look at the third line down, here's line 1, line 2. The third line should say radian, and then it should say degree. Now, one of those is highlighted. So whichever one is highlighted is the mode you're in right now. Now, let's say that you're in degrees and you want to go to radians. Well, then you take your arrow button and you would push it, and this highlight will jump over to radians. Go ahead and try that if you want to, okay? Or, well, first of all, scroll down until your cursor is on the third line. So make sure you scroll down until your cursor is on the third line. Okay, I apologize. It should have been on your first line where it says the word normal up top. So scroll down, and then you can go to the left or to the right, put your flashing cursor on radians and hit enter. And now radians is highlighted. So now you're in degree. Now you're in radians. Okay, go ahead and hit the right arrow button and go back over to degrees, and now hit enter. And that's it. You don't have to, all you have to do is hit second quit. So see this, look right here at the screen, students. See this quit button right here, or see the quit word right here, I'm circling it. Once you've highlighted what you want, you can hit enter. You don't have to, really, you just highlight what you want, and then you hit second, and then hit mode, which really means quit. So hit second and then mode, and make sure degrees was highlighted, and now you're in degrees, okay? All right, moving on. Now let's find the sine, cosine, tangent, cosecant, secant, cotangent of 28 degrees. And of course, this is really easy. See your sine button right here? You simply just hit sine, and when you push that on your calculator, this is going to pop up on your screen, sine, and then a parentheses, and then type 28. And you don't have to close the parentheses. You can if you want to, but you don't have to. You don't have to close it at all. Just hit enter, and you're fine. Sine of 28, and you should get this right here. You should get 0.46. Usually we round to 4 decimal places, 0.46947, so 0.4695. Let's find the cosine of 28. So hit cosine, which is right here, and then hit 28 degrees, and then hit enter. And when you do that, the cosine of 28, this should pop up on your screen, 0.8829. Okay, well, next would be tangent. So let's go ahead and hit the tangent button, which is right here, right beside cosine. So you hit tangent, and up pops that parentheses. You put 28. You can close the parentheses if you want to. You don't have to. Tangent of 28 is going to give you 0.5317. Now, here's where it gets a little tricky. Nowhere on your calculator are you going to see cosecant, secant, or cotangent. None of those are there. Okay? And no big deal. That's fine. What you're going to do is simply this. Okay? You're simply going to, remember, cosecant is the inverse of sine. Remember that? So with your calculator, go back up, and I want you to hit sine of 28. Now just trust me. Hit sine of 28, and then hit enter. Okay? Now when you do that, you're going to see this on your screen. You're going to see 0.4694715,628. Okay? You're going to see a big old number like that. And I wish I could make that a little easier to see. Well, I shouldn't have done that. Okay, students, I'm back here. Let's try this a little differently here. 0.4694715,628. And let's see if we can't kind of condense that down a little bit if at all possible. And I think I'm making this a little more hard than it is, so I apologize. So on your screen, go ahead and hit sine of 28, hit enter, and I'll write a little smaller this time. You're going to get 0.469471562 Now, in order to find cosecant, all that you have to do is hit this x to the -1 button. Do you know what that x to the -1 button means? It just means whatever is on your screen, you're going to take it to the -1 power. And remember, when you take something to the -1 power, it flips it. In other words, 2 to the -1 power, if you flip 2, you get what? 1/2. If you were to have 3/4 to the -1 power, that flips it 3/4 to the -1 power is 4/3. So all that you have to do, now see if this makes sense. Stay with me, okay? Remember, we're trying to find the cosecant of 28, and there's no cosecant button. But we know cosecant is the inverse of sine. And so, with that in mind, we find the sine of 28, and after it pops up, then hit your -1 button, and now hit enter. And it should say this. When you hit the -1 button, it should say this. Hold on one second on the screen. It should say answer -1, and then hit enter. And you'll get this right here. 2.13005 or 01. There we go, we did it. Okay, so we found the cosecant of 28 degrees. Now let's find the secant of 28 degrees. Now in order to find the secant, there's no secant button over here, but we know secant is the inverse of cosine. So we're going to type in cosine of 28 degrees, all right, cosine of 28, and when you do that, you're going to get 0.882947 5929, and then hit your -1 button because you want to flip that, you want to invert it, and this should pop up on your screen, answer to the -1, and then hit enter, and you'll get 1.13257, or in other words 1.1326. Now I'd like you to try cotangent on your own, okay? There's no cotangent button over here, but cotangent is the inverse of tangent. So go ahead and try that on your own. Hit tangent 28, enter, then hit -1, enter, or -1 power, enter, and you should get this right here, 1.8807. There we go. So we very quickly learned how to find the sine, cosine, tangent, cosecant, secant, cotangent when given a right triangle or when using a calculator. Now, I want to end with some advice on memorizing your trig ratios, and please listen to me. You'll really like this, okay? I think you probably learned this in earlier classes, but sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. Well, we have SOH for sine, SOH. We have CAH for cosine, and we have TOA for tangent. There it is. And we always say so, ka, toa. Okay? Long O's, short A's. So, ka, toa. So if you can remember this catchy little expression, SOHCAHTOA, SOHCAHTOA, then you'll remember so, sine equals opposite over hypotenuse, ka, cosine equals adjacent over hypotenuse, toa, tangent equals opposite over adjacent. So, ka, toa. And then from there, all that you have to remember is cosecant is the inverse of secant, secant is the inverse of cosine, and cotangent is the inverse of tangent. So cosecant would be hypotenuse over opposite, and so on and so forth. This would be hypotenuse over adjacent, and this would be adjacent over opposite. So I hope that helps you memorize these a little better. You've probably heard of that before, okay, but very, very extremely quickly. Let's review. What we want to learn today is how to find the 6 trig functions when given a right triangle. And here's your ratios right here. You need to have those memorized and know those, okay? And then when you're given just one bit of information like this, cosine of theta equals 5/7, you should be able to draw the triangle, find the third missing side, and then find all 6 trig ratios. And then you should be able to find your 6 trig values of a given angle using a calculator. Okay? If you have any questions, don't hesitate to call or email.